So this is a basic F equals ma example. Got my trusty calculator here. What we're going to look at here is how we can take F equals ma and just apply it to something very basic. Right now, we are not going to include any friction in our problems. We'll get there. But right now, we're just going to pretend that only the forces that we say exist actually exist. Okay? So in this little example we've got here, let's pretend for a second on, let's make the ground green, I guess, right? Let's pretend on a nice flat surface with no friction that I have a box. Whoop. Okay. And I'd like to push this box. I don't know why I made the torso so big and the feet so small, but whatever. You'd like to push the box to the right, okay? The mass of the box equals, let's say, 4 kilograms. And let's say, due to your strength, the box begins to accelerate at 1.8 meters per second squared to the right in the direction that you're pushing it. Okay, just how much force did you push on the box then? This isn't a crazy scenario here. We're just using F net equals ma, so we can just say that F, and remember this is F net, it's the sum of the forces, like I said before. Some people like to write this as a sigma. Some people like to write this as F net. Some people just like to call it F because we all understand what that is. And that just equals ma. In our case here, the mass is 4 kilograms. The acceleration, 1.8 meters per second squared. We just multiply them together. 4 times 1.8, boom, done. The force you're pushing with is 7.2 newtons. That's it. That's how quickly you can do a problem like that. And that's just like the most basic example of a problem there, okay? I could give you a slightly different problem here. I could say you're pushing with 7.2 newtons on a 4 kilogram block. What's the acceleration? I could say, hey, you're pushing with 7.2 newtons and the box accelerates at 1.8 seconds. What's the mass? In which case, depending on what you're trying to solve for, you either have, you're solving for force, F equals ma. You can solve for acceleration, that equals just force divided by mass, just dividing the mass over. Or if we do the same thing for the mass, that is just a force divided by an acceleration. I don't like to really draw this a lot, but I know some of you are comfortable with it. There is this triangle thing that I know some teachers love to use. Whatever floats your boat. What we have in this triangle, I guess a easy way to write it is, what would this be? F A M, and then you can read this as F equals ma, or A equals F over M, or M equals F over A. Some people like to do that. I've never been a fan of it. Just do the algebra like a real human, and you should be fine there. Okay, but that's a very intro basic problem there for some forces. Okay.